We've now been used to algebra tiles in class. We've been introduced to them. A quick reminder, an algebra tile, we have a few different sizes. There's 3 different sizes that we've talked about. The first one is this little square right here. This one has a side length of 1 and a width of 1, making it area 1. Each one of these squares is worth 1 unit. It is a constant. We know its area is 1 times 1. Now remember, on this one, that's a terrible drawing, that's okay. I have one side length that's 1, but this side is an unknown. It's a variable x. So we call these tiles, these rectangular ones, x tiles. And what we're going to work on today is extending what we've talked about with the distributive property to use algebra tiles. So instead of using just numbers with the distributive property, we're now going to be using variables. Variables are items that have unknown values, but we can still apply mathematical properties to them and show that they will still work. So here, first thing we do is let's take a look at what we have. So I have 1, 2, 3 pieces that are called x. So I'm going to write that down. I have 3 x pieces. And then I also have, I'm going to count up my units. I have 1, 2, 3, 4, 5, 6. I have 6 units. So I'm going to say 3x plus 6 is the area that I have represented right now by these tiles. I'm going to organize my tiles so they're a little easier to work with. And they easily organize into 3 rows. I still have my 3 x's right here. And then I have my 6 unit pieces next to them. If I was going to then draw this, I have some options. The first option would be to say, oh, well, it looks like I have 3 different tiles that are all x's. And I would say this is a group of 3x. And then the area, if I want to keep it the same area and show how the distributive property is working here, I've put these in a group also, and now I have 3 groups of 2 each. You can see right here, each row is a set of 2. 3 times 2 is 6. I have 1, 2, 3, 4, 5, 6 units here. 3 times x's, well, I have 1, 2, 3 x's. So what I've shown is just simply that the exact same area of the grouping I had before. I can say that 3x plus 6, it can equal to 3 times x plus 3 times 2. I see another arrangement that I could make by drawing these another way. So because they're evenly in groups of 3, I can show a group here, and a group here. So if I was going to draw this out, I would say, okay, well, I have an x, and then right next to that x in that row, I also have 2 units. So here's my x, here's my unit, and my other unit. So that looks like that is x plus 2 all in a group together. And I can show that 2 more times to show that there's 3 of them. I'm representing the same amount, just with my tiles arranged in a different way, and with my picture looking a little different. This is important because we're using this as a model to show how the distributive property works. In this case, what I've drawn is a representation that shows that I have 3 groups of x plus 2. I haven't changed the area, so that also shows that 3x plus 6 is equal to 3 times x plus 2. And using this idea, I'm now going to build a model. Now I want to build a model that has an area equal to 4 groups of x plus 1. So I need to first draw a group that is equal to x plus 1. So I would draw an x tile, and I draw 1 unit right next to it. So this is a group showing x plus 1. Then I need to repeat it 4 times. I always want to draw the picture exactly how it is presented in the equation. I want to model the equation, the expression. So now I've got 4 x's and 4 1's, and I can take a look and see what is the total area. I had 4 groups of x plus 1, And if I look at that and I just count them up, I would see that I have 1, 2, 3, 4 x's plus 1, 2, 3, 4 just single units. So that equals 4x plus 4. The other way I could write that out is I could rearrange it differently, and I could show, well, if I had a group here and I arranged these exact same tiles into a group that had 4 x's, 1, 2, 3, 4, and then 4 single units right next to it, 1, 2, 3, 4, that would show that I can also have this area 4 times x plus 1 represented by 4 times x plus 4 times 1. Different ways of representing the exact same amount. Okay? In this form, we are seeing the common factor of 4, so this would be called factored form. In this equation, we see that the 4 is being distributed. Here it is with the x, and here it is also with the 1. So this is the distributed form of the equation. In algebra, we can only combine like terms. 4x plus 4 is the most simplified version because it has the 4 distributed, and it has been simplified with combining like terms as far as possible. And that's the basics of how you would use algebra tiles to show the distributive property. Your assignment is to do GC 54 and 55 in your book. Make sure you have evidence that you've watched this video because we'll be checking it for homework tomorrow. Okay, bye.